Sir has earned PhD and MTech degrees from MNIT, Allahabad. Sir has 17 years of teaching as well as research experience. Mobile computing, blockchain applications, and IoT QoS are his area of interest. Sir has published 13 papers as well as chapters in various reputed journals like SCI, Scopus, Web of Science, Scopus, SCI Expanded. We heartily welcome you, sir, for the session, and the session is yours.
Thank you. So, if you permit me, ma'am, can I share my screen?
Sure, sir, you can share.
Yeah. So let me share my screen. So I hope my screen is visible to you all.
Yes, sir.
Okay. Right. Thank you very much, ma'am, for inviting me for delivering this session on very upcoming technology, very futuristic technology, that is blockchain technology. So today I am going to cover the current current practices and what has been done in the past and what is the future of the blockchain technology. So we'll begin with the transitions in computing from starting from the mainframe days and then centralized PC days, and then now we are inching towards the decentralized platforms. So, and then we'll start about the blockchain technology and how it has started, what is its timeline, and why we need this technology, what are the benefits and how it works, and various elements of the blockchain technology, the various popular famous blockchain technology platforms, and the cryptocurrencies. So many of us are having an idea or a myth that a cryptocurrency like Bitcoin is same as blockchain. But I'll make it clear that they are not same, they are different. So, and then we will also discuss few of the use cases. We'll discuss about the smart contracts and how the smart contract works inside the blockchain, different tools and technologies that are there in the blockchain space, which developers are supposed to use for the development of their decentralized applications, that is DApp. I'll also discuss the typical steps that are required to deploy your decentralized application. And then in the end, we will have a Q&A session. So if I'll welcome your questions in the end. Right. So we have witnessed, many transitions in computing paradigm. Like we started with the mainframe computing for the computing intensive applications. Okay, like when we are having different applications which require larger or very strong processing power or resources. So in the beginning, we were majorly bounded with the mainframe computers. So mainframe were having stronger CPUs, stronger resources, and all the terminals which were called the dumb terminals those days. That those terminals were having only some connectivity, some peripherals associated with them, but they were not having major resources, right? So at that time, everything was centralized on the mainframes. So that those were the completely centralized days. Okay, so those were like that kind of computing paradigm or architectures were there in the beginning, starting from 60s. And then as the computing resources became somewhat affordable, so then from 70s onwards, so your personal computers were starting growing in the business, and these were becoming affordable for people. So then the personal PC computing was started, and then there was a proliferation of the networks. So in the 80s, the network computing was started when the various LAN and WAN connected together, and then so internet becomes very prominent till the 90s, and then after the internet computing, the grid computing came up, and then cloud computing, and then we are still growing. So in centralized kind of systems, the computing power, storage, infrastructure, protocol, and the code was actually centralized, and that for this your dummy terminals were there, or even PC was there. Like when the PC were having, like personal computers were having some of the storage and some of the computing power. So some of the computing was transferred from the servers to those PCs. So that kind of system was like client server system or client server architecture. So then, so that kind of system was having their own drawbacks, like single point of failure, or maybe the dependability on a particular server for the service. So then we further go ahead, and then we witnessed about the grid computing and then cloud computing. So, but still we were centralized. Even in grid and cloud computing also we are centralized. So some nodes are like cluster based, forming the clusters, and one cluster head is there. So that cluster head will work as a centralized server or centralized node that will coordinate the function of all the node connected with that cluster head. Similarly, in case of the cloud computing, we are having such the dependability on those some very powerful servers. But still, what the idea is that how we can remove those dependability factors on the centralized systems. So now we are moving towards the decentralization, and more of a decentralization of all the resources, all these resources like computing power, storage, infrastructure, protocols, and the code that is basically centralized on a machine. But we are now interested in the coming business cases that these should be decentralized, and these should be available on all the nodes rather than on a single node. So that will actually give the sense of belongingness or sense of ownership for all the persons who are participating in it. So with the help of decentralization, we can implement the true democratic systems. True democratic systems can be implemented with the help of the decentralization of the resources, right? So we are now inching towards the decentralization, right? So I hope my slides are changing. Can anybody confirm me that whether my slides are changing or not?
Yes, sir. Yes.
Yeah, sure. Thank you. Thank you so much. So we are now inching towards the decentralization, and there is a so these systems basically are aiming to give an explicit control of digital assets to all the participants, to all the stakeholders who are the end users, and they are trying to remove the need to trust any third-party servers and the infrastructure. So the idea and the complete objective of the decentralization is to remove the role of third parties, or to remove the role of third-party servers and the infrastructure. For example, if you are doing banking, so there is an RBI regulator that is the third party, and with the help of the RBI, different banks are there with which the customers are connected. So if we are like only we have to do the transaction, I have to send the money to someone, and someone else has to receive the money from me. So what is the need of these centralized systems? So yes, because there is no strongest mechanism to establish the security, integrity, and availability. So that CIA kind of system, that if that system is becoming stronger, or is available, and if it is secure, and if it is having the integrity, so in that case we can create the total decentralization, and we can eliminate the role of those third party systems, right? So the complete objective of the decentralized system is to eliminate the role of third party. Now, for the purpose of making it possible, we are having a concept that is known as distributed ledger technology. So everybody is aware about the databases. So yes, we are also aware about the distributed databases. Or in your decentralized systems, the main concept will be of decentralized ledger technology. So this DLT is one of the key innovation that is making this decentralization possible. So what this DLT is? So basically, as you see here, like in a decentralized ledger technology, all the stakeholders are connected over a peer-to-peer network. All the stakeholders are connected over a peer-to-peer network, and like in a distributed ledger. So like a distributed ledger is what? So ledger is basically consisting the records. Okay, so a ledger is consisting the record. Now how these records are distributed across the stakeholders, or across the peers, or across all the participant of a system, right? So this distributed ledger technology, or a distributed ledger, is basically a data structure which is spreading across the multiple computing devices. And these computing devices are either your mobile devices, or your your laptops, your PC, your desktops, everything. And they are basically these devices are generally spreaded across the geographies and across the geographical regions, right? So a distributed ledger is kind of a data structure which is spreading across the multiple devices, and these multiple devices are spreading across the geographies, right? So this DLT is basically a technology infrastructure, protocols that facilitate simultaneous access, validation, and record updating in an immutable way over a peer-to-peer network. So as we all are aware that peer-to-peer network is kind of a network where there is no centralized server. There is nothing which is controlling a server. All are equal, all are peers. And like for example, we are having a torrent. So from the using torrent, we download different movies or videos or high voluminous data, which is being shared by some of the other participants. So like we have different examples like DC++ or a torrent or Kazaa, Napster. So these all are the examples of the peer-to-peer networks, right? So this whole DLT is basically implemented over a peer-to-peer network, and this peer-to-peer network is hosting the this whole decentralized systems. Okay, and if we want to summarize like what the DLT consists, so basically DLT consists three major things. That is a data model, a language of transactions, and a protocol that is used to build consensus among these participants. So there are multiple things that has to be considered, like three things major. That is a data model that captures the current state of the ledger. Okay, so for example, if a participant is trying to do a transaction, so on the particular thing, then that user will have a data model. So that data model will capture the current state of that ledger, which is spread across all the stakeholders. And we have a language of transactions that changes the ledger state. So this language of transaction is used to write the smart contracts. So basically, these smart contracts are written and these are available inside the blockchain, inside this decentralized ledger technology platform, which is actually a blockchain. And those smart contracts are driving the transactions. Okay, so we'll discuss about the smart contracts a little later. And so we have to have a language of transactions or language of smart contracts. So the language of smart contract is like, for example, Solidity, for example, Golang. So Solidity is a smart contract programming language that is used for the Ethereum platform. And we have a Golang that is used in Hyperledger blockchain. So we have different languages like Rust programming. Also, there is one language that is used for writing the very robust and integrated kind of smart contracts, which are very secure in nature. So we have different languages of transactions. The third one is that how we can build the consensus, which is a major thing inside the distributed ledger technology, like consensus among all the participants which are participating in the this distributed ledger. Okay, so this protocol which we are using, like for example, we are using some consensus protocols like proof of work or proof of stake, or there are some many other which are improved version of these. So basically these are used to build a common consensus among the participants and around which transactions will be accepted and in what order by the ledger in which the transaction has to be recorded. Okay, so decentralized ledger technology is very important to understand the blockchain technology, because it is a driving force. It is changing the nature from centralized towards the decentralized. So before discussing the blockchain technology in detail, so let us understand the historical development of its that was started way back in 1982. So that time nobody was knowing that okay, so that kind of protocol will be known as blockchain in the future. So in 1982 it was proposed in the literature, and then in 1991 it was described cryptographically secure chain of blocks, and then in 1993 Merkle trees was the data structure that was incorporated, and Merkle tree is even today with the blockchain, they are very popular and they are used for storing the summary of all the transactions in the form of the trees, in the form of the all the nodes which are having different records. And then in 1998, so there was a concept of bit gold, because at that time it was just beginning of the digital revolution. So and then in 2008 and 2013, so Ethereum was started in 2013. Your Bitcoin was started in 2008 by Satoshi so in Japan. So basically Satoshi Nakamoto, and then in 2013 the concept of Ethereum was started, which is public blockchain. And then Hyperledger was started in 2015, which is basically a private version or permissioned blockchain. So there are two types of platform, that is private blockchain and the public blockchain. So they are having their own use cases, their own target customers. And then now we are inching towards Ethereum 2.0, and we are still evaluating. So blockchain is still in its infancy, and many of the business houses are still in the process of making decisions whether they have to go towards the blockchain or not. But still, if the business houses are having a vision, then definitely many of them are already migrated, and they've already decided that they will move on this blockchain technology platform. All right, so then now let us understand why this blockchain technology is important. So basically, blockchain is emerging as an ideal technology for faster, accurate, and secure information transfer. Why? Because See, it provides immediate, shared, and completely transparent information stored on an immutable ledger. So a blockchain network can track orders, payments, accounts, production, and much more. So the major thing in a business is that how we can track the responsibility, how we can track the orders, how we can trace the responsibility, how we can make certain entities responsible for the certain outcome of a decision. For example, if we are running an ice cream business, okay, or if we are running a dairy business. So in case of dairy business, so if you are transferring the dairy products from one location to another geographical location, so that will be with the help of some of the trucks which are air conditioned, and they will be storing those dairy products or ice creams kind of a products, and they will maintain the temperature which is required to keep the items fresh, so that they are consumable and they will be delivered to the customers. But if on the way somewhere in the warehouse or in the transition, if the temperature goes down and the item becomes not eatable, or it becomes it is becoming something which is not healthy for to eat, so then that product will be wasted and there will be a loss of business for certain people. So then in that case, how we can track that who actually who to whom we can make responsible or held responsible for that particular kind of task, which actually change the temperature of that particular product on the way or in the warehouses or maybe at the retail end. So we can trace or we can track all these things if we are having a build blockchain of complete solution from the manufacturer till the end user customer. So that can be done with the help of blockchain technology. So basically blockchain is providing trackability of all the orders, payments, all the accounts, production, everything. So whatever the, like, if it is manufacturing, agriculture, or even healthcare, or like wherever there is a need of keeping transactions, financial technology, that is fintech, which consists almost like blockchain technology is like now implementing that fintech for more than 80-90% of the applications. Then members share a single view of the truth. So that is also one of the benefit of the blockchain. So every member is like participating in the consensus process, and then you can see all details of a transaction end to end, giving you greater confidence as well as new efficiencies and opportunities. So now we can understand that why blockchain is emerging as an ideal technology. Okay, so these are the regions that actually we are building the systems to run our businesses. So businesses are basically creating the ecosystem and the complete ambience for the society. So how we can keep track of all the activities, all the decisions, and how we can make people responsible, how we can hold them responsible for certain decisions. So that consists at every juncture in the business. So basically, that is why blockchain is going to replace all traditional kind of platforms in the future. Right. So as I said, any business runs on three different things. That is computing infrastructure, which consists the your all CPU and all different cores of the computing infrastructure. Storage, how you are storing inside the blockchain, or if you're not using blockchain, then in some databases, and the communication, how the communication is taking place between the nodes or between the computing infrastructure. So these three things are basically, or three parameters, three components are driving any business logic. Excuse me. So now, to have more efficient business, so what needs to be changed? Okay, so operations often waste effort on third-party validations. So, for example, we are interested in removing all the overheads. We are really interested to have in the business only which is really important for the business to run. We don't want to keep any external overhead. So we want to remove that. So one thing. Second thing is that record keeping systems can be vulnerable to fraud and cyber attacks. So if you are keeping something on a particular single location, so that can be vulnerable for attack. So if we are keeping that on a system such as IPFS, IPFS is a distributed database which is used in the blockchain. So in that case, if somebody is trying to attack one particular node, so that node may be isolated, because that node will become odd one out inside all nodes. So in that case, the record keeping systems will be safer when we are using blockchain. So we have a limited transparency that can slow data verification, and with the arrival of many tiny devices like IoT devices and sensor devices, the volume of transaction is emerging and exploding very highly. So these are the things which we have to change in the business. So all of these things are basically these slows the business, and if we are slowing the business down, then definitely our growth is slow, and we don't want that our growth should be slow. So that means we need to have a better way, and that better way is now there is a solution for that. So that is leading towards the emergence of the blockchain technology. Right now, let us focus that what is the blockchain technology and how it basically works. So now here onwards, so blockchain technology is a technology that is used to run the trusted exchanges in the digital world. So now we are doing everything online, and a blockchain consists a process of recording transactions executed by peers through a common consensus algorithm in an immutable peer-to-peer distributed ledger using smart contracts and other technologies. Right? So there are things which are part of the blockchain, that is the common consensus algorithm, smart contracts, distributed ledger. So these all are part of the blockchain. And these immutable peer-to-peer distributed ledger means that once the record is committed over the blockchain, that block will not be deleted. That block will not be tempered by any of the participant. If there is a need to change something or modify something, the new block will be added, and that new block will be added, and it will be present along with the old block also. Right? So then that means you cannot replace an old block. You can create a new block and you can add the new block, but the old block will be there in the system, and it will have a link with the newer block. So there is a chain of blocks that are basically defining how the business is processing. So a blockchain is maintained with a peer-to-peer network of mutually untrusting peers. Nobody knows on the blockchain to whom we are talking, to whom we are doing business. Like for example, in case of the cryptocurrencies or crypto trading, you are having only one 64-bit public address. So that public address is only identity that you are having in the blockchain. Nobody else can identify. There is no KYC. Now people are doing some KYC, and some regulation is coming up in the blockchain, but still like there is no KYC in case of the crypto trading. So only that 64-bit public address is the identity of an user, and nobody knows that to whom you are selling your crypto and or from whom you are purchasing the crypto. So every peers basically maintains a copy of the ledger. That means you can say the ledger copies are basically stored on every node, and the peers execute a consensus protocol that validates the transactions and group those transactions into the blocks and build a hash chain over the blocks. So this hash chain is basically making the blockchain secure. So there are separate hash algorithm, like for example, secure hash algorithm SHA 512, or maybe there is a keycheck 256 hash algorithm. So these are the hash algorithms which are being used for the purpose of making the blockchain secure, and every block is connected with the previous block with the help of that hash. So this process forms the ledger by ordering the transaction as is necessary for consistency. Right, so we understood the idea of blockchain, why we need blockchain, and what is blockchain. Now, these are four main elements of a blockchain. So as we discussed about the distributed ledger technology, DLT, that is the most important element of the blockchain. Immutable records, that are the part of the block, that is one of the most important element. Consensus algorithm, like for example, proof of work, proof of stake. So these are consensus algorithms which basically establish the agreement amongst all the participants or peers to have consensus. So if we are having n number of peers inside a peer-to-peer network, so we need the agreement from more than 50% of the peers to validate a transaction. So who will validate? So there is a you can say kind of a competition. Like in case of proof of work, so there is a puzzle that is being given to all the nodes, and those nodes are basically solving that puzzle. Whosoever is first solving it will be given the opportunity to validate or mine the blocks. Then we have the fourth component, that is element, that is smart contracts or chain codes. So a smart contract is a term which is we'll discuss just after a few minutes. And like chain code and smart contracts are synonymous. So in public blockchain, the term smart contract is used. In private blockchains, we use the chain code, but the meaning is same for both the terms. So these are four different elements of a blockchain that we generally have in any blockchain. Now, how the blockchain works? Okay, so we have different steps of like working of the blockchain. For example, a client who are part of the blockchain wants to do some transaction. So the client initiates the transaction, and then the transaction is given to all the peers over the blockchain for the validation, so that peer-to-peer network, whosoever is part of that blockchain, will receive that transaction, and then all those nodes will validate that transaction, and then after the validation there will be a verification, and that block will be added. Like there is a new block here which is added, and then this will be connected with the hash in the previous block. So the hash will be stored here also and here also. So and then this, after this verification, all the details are verified, and then block is committed over the blockchain. And then, like for example, in Ethereum blockchain, so there is a ether scan that is available. So once the block is added, you can see the detail of that block on ether scan, or maybe like Polygon scan. Polygon is also one of the blockchain, Indian blockchain. Okay, and Hyperledger is having its own online platform, so that will show you the transaction and the blocks. So it is very transparent. Whosoever is having the or participating in that process can see all the transactions that are done inside that. But who is doing the transactions, it will not be identifiable, right? So for example, if with the help of Bitcoin transaction, we can also understand how blockchain works. So if there are two users. So A and B, if A wants to send some bitcoins to B, so then the transaction is mined and represented online as a block, and then the block is broadcasted to every node in the network for the validation purpose, and then every node validates that, and the other nodes in the network approve after the validation that the transaction is valid, and then the block can then be added to the global ledger, the blockchain, which provides the indelible and transparent across the different nodes. So that will be done, and then finally the bitcoins are deducted from A's wallet and added to the B's wallet. So the number of bitcoins that are sent from A to B will be finally appearing in their wallets. So this is also one of the example of working in terms of cryptocurrency Bitcoin to understand the working of the blockchain. All right, so basically what is inside a block? Okay, so block is basically a bunch of transactions that have been added to the blockchain. So you can see here there are n number of blocks, and every block has its version, its Merkle root. That Merkle root consists the summary of the transactions in terms of the Merkle tree, and then we have hash of the block n-1, that is nth block will have the hash of that is previous block n-1. Okay, and there is a nonce, there is a difficulty target, the state of the transactions in terms of balance, code, storage. So everything is visible inside the block, and then detailed information of the transactions that is available in each block. So in such a way, every block in the blockchain is connected, and this information is available inside every block. All right, so now let us understand about the consensus algorithm a little bit. So basically, a consensus algorithm is a process for the peers to reach at a consensus of acceptable real-time state of distributed ledger. Okay, so we talk about like how the agreement is achieved on a particular transactions inside the blockchain. So whenever we say that there is a need of achieving or establishing a consensus over a transaction, in that case, so we have to run a consensus algorithm like proof of work or proof of stake. Proof of work is a kind of where we provide a puzzle and we test the available computing infrastructure and storage infrastructure at a node. Proof of stake is like whosoever is having higher amount of stake of maybe cryptocurrency or tokens. Okay, so in case of cryptocurrencies, we say number of cryptocurrencies. In case of non-cryptocurrency applications, we say that the tokens. So on the basis of certain consensus algorithms, the state of distributed ledger is modified, is changed. So if all the nodes inside the all or majority of the nodes inside the blockchain, if they are agreeing on modifying the state of distributed ledger, then only it is get modified, and it is basically added into the new block, not into the existing block. All right, so who is responsible for this execution? So we have smart contracts or the chain code. So everybody understand what is a contract. So contract basically consists some of the conditional set of rules which are basically signed between two or more parties. But the smart contract is a computer program which is stored on the blockchain and executed automatically. So if I say automatically, so that means on the basis of satisfying certain conditions inside the program. For example, whenever we are transferring the salary of employee on the last day of a month, so the condition is satisfied if it is the last day of the month, so there will be a transaction that will be triggering from the account of an employer to the accounts of the employees, and then the salary of the employees will be transferred from the employer's account to the employee's account. So that can be done on the basis of the smart contract, which consists of program, which consists set of rules in terms of the conditional statements, and then if then else kind of a system, and then that transaction is completed. And then we have like the example of like the corporate bond transfers. So on satisfying a particular condition, the corporate bond transfer can also be done through the smart contracts. Or we can have the implementation of the travel insurance that is to be paid to the passengers or travelers. So on the basis of the smart contracts or chain code that is written in a particular programming language, for example, Solidity, Golang, Rust, or even Python also, JavaScript also. So these are the languages in which we write these smart contracts, and then they are executed on the satisfying of the particular conditions, right? And now how these smart contracts work. Okay, so as I said, a smart contract applies a simple if, when, then format in a code on blockchain such as Ethereum. So as I said, so a smart contract is a program or a set of rules in which we are having some conditional statements, and those conditional statements are basically in the form of if and then. So with the help of that if then, the smart contract will be executed, and accordingly the actions will be taken place. And then the nodes connected on a peer-to-peer network execute the smart contract after satisfying some predetermined conditions such as fund transfer, vehicle registration, notification broadcasting, and ticket generation. So there are a lot of use cases in which we are basically trying to deploy that business onto the blockchain. For example, the vehicle registration system. So if a vehicle is purchased and all the conditions are satisfied, like the bill is paid and the manufacturer has provided a vehicle, and then the consumer has agreed upon the terms and conditions of the manufacturer and retailer, and then there is a kind of smart contract that is running between all these parties, and then vehicle registration can be executed automatically. Fund transfer that we have already discussed, or maybe if we are broadcasting a notification to the public. So if there is a certain predetermined conditions is satisfied, these specific outcomes or decisions can be taken on the basis of these smart contracts. So the transactions are committed on the blockchain after execution in an immutable and permissioned manner. So maybe we have a permissioned blockchain, or maybe there can be a public blockchain also, where every peer is not dependent upon any other peer. But in permissioned blockchain, still we are having some kind of authentication mechanism. With the help of that, only the node can join or leave the blockchain. Then we can write all the terms and conditions of all the peers after their consensus, and then the peers must find the way their transactions are appearing on the blockchain, consensus rules that drive those transactions, exception handling, and a dispute resolution framework. So these all are part of like smart contracts. And then finally, a blockchain developer will write a smart contract for it, and the organization use simplified contract structures with their own web applications, templates, and other online tools. Right. So after having an agreement, then we can write a smart contract in a particular programming language, and then that smart contract can be deployed over either a public blockchain or a private blockchain, and then the organizations themselves can customize those smart contracts according to their own conditions. Right. For example, they can have their own web applications. Like they can have their own templates for storing the records onto the blockchain. They can have their own online tools that will be that will be operating in their business. So that can also be like part of the smart contract. So the smart contract can be customized once the smart contracts are written and deployed over the blockchain. Okay, so with the help of this slide, we can further understand that how the smart contract basically works. So there are some predefined contracts that consist the terms and conditions that are agreed by all the parties which are involved in the business, and then that smart predefined contract is executed of the contract and is triggered as an event. So with the help of smart contract writing language, we are creating that smart contract, and the events are executed and triggered. And once these events are triggered, then there are smart contracts that are executed automatically when the predetermined conditions are satisfied. And then finally, the settlement, that is, all the statements are executed quickly and efficiently, all the statements. So these are the steps, these are the, you can say, chronological order in which our smart contract works. That is predefined contract, then events triggering, and then execution of the contract, and then final settlement of all the executed blocks, and then finally storing those blocks onto the blockchain. All right, so this can be a simple example of the smart contract working. So we have like different real estate kind of a business. So there is like somebody is selling house, somebody is interested in purchasing that house. So we don't want to have any agent. So a smart contract is written, and that smart contract will provide everything to the buyer and to the seller, and for all the for all the registration purpose, like registry. So from the registry also, like people from the registration department, from the government department, they will participate into the blockchain as a stakeholder, as a peer, and then they will validate the transaction according to the intent of the seller and buyer, and then the complete smart contract will be executed. Right. So this example is one of the example. Another example can be like the example of a supply chain. So where, like for example, we are supplying some of the products or maybe raw material to an organization who is producing some products. For example, the auto sector. In auto sector, we are providing some of the parts. Some companies, some vendors are providing the parts. So we can track that when the part was delivered, when the part was assembled, and when it was getting built, and then finally invoices generated, and then finally how it is getting paid, and it is settled. So there can be many use cases that are basically suitable for the blockchain implementation. So I don't say that all applications are suitable or all businesses are suitable for blockchain, but now majority of the blockchains, majority of the businesses are basically suiting towards this blockchain platform technologies. All right, so now quickly we have to discuss about various blockchain platforms. Like we have two types of blockchains, as I said: public blockchain, private blockchain. And these public blockchains are known as permissionless blockchains, and private blockchains are known as permissioned blockchain. And there are some hybrid kind of blockchains also. So in case of public blockchain, there is no central authority, like for example Ethereum. So in Ethereum, we don't have any central authority. But since many of the organizations don't want, okay, we should have some control at least inside the blockchain. So for that purpose, there is a controlling by one authority inside the blockchain. So like for example, maybe for the authentication purpose, they are providing the permission for all the peers to get part of that blockchain. And like, for example, we are having the employee of an organization. So if the employer wants, only the employee should be part of that blockchain. So there is a system of authentication. So private blockchain requires some central authority, some single, but public does not require any central authority. For example, your Bitcoin trading or Ether trading or the Ethereum blockchain deployment. We also have hybrid, in which we have some part inside it is public and some part inside it is private. So there is blockchain which is not requiring any control of the single or central authority, but overall there is some part which requires the authentication or the permission from the central authority. Also, we have the consortium of the blockchain, where a group of companies or group of organizations are collecting together and they are forming the blockchain, and then they are being controlled by a group. So there are different kind of platforms that we can have, and we have these platforms which are available and nowadays in the blockchain space. So we have like Ethereum, we have Ripple, we have IPFS, Solana, Tezos, Stellar, Near, Hyperledger Fabric, Polkadot, Neo, Cardano, Polygon. So there are these are different now. Also, some new blockchains are coming up. So basically, some are completely open source. Some are the enterprise, or you can say, so they are paid also. So these blockchain platforms are like, whenever we are trying to, or whenever we are planning to implement any of the decentralized application, we have to use any one of these blockchain platforms. So as we discussed from the beginning, that the benefit is like there is an automated trust from the blockchain. So nobody has to trust anybody. If I am part of the blockchain, I don't need to trust anyone. Or there is a process of establishing a trust. So there is an automated trust. There is a greater security because we are using hashing between the blocks, and no block is connected without a hash. More efficiency because the retrieval time is becoming less. It is becoming faster because of the availability of the transactions over the peers. Right now, let us quickly discuss about the cryptocurrencies. So we need to understand what was before the cryptocurrency and what is after the cryptocurrency. So basically, a cryptocurrency is an internet-based medium of exchange which uses cryptographical functions to conduct the financial transactions, right? So if we talk about before the cryptocurrency, so it was like everybody, like many of us know about the PayPal, or maybe the Visa, MasterCard, or Western Union. So there are the middlemen. They were the middlemen between the customers. Okay, so now, but now there is no one between the customers, with end user peers, between the two parties. Okay, so there is a greater change. So there is an elimination of all these third parties or middlemen, that is like Visa, MasterCard, PayPal. So these all are eliminated, and directly the peers or customers are doing the transactions between them over a peer-to-peer, open, secure, and very efficient network. So the property of the transaction is property of the cryptocurrency is like they are completely digital, they are completely decentralized, they run on a peer-to-peer network. All the businesses, all the transactions are handled on a peer-to-peer network. So there is a property of pseudo-anonymous. So nobody knows that who you are inside the cryptocurrency space, as I said in the beginning. So you have only one identity, that is your 64-bit address. So there is like, you don't have to trust anyone. Your trust is automated there. The transactions are encrypted, and the the business or trading, crypto trading can be done at the global level. Like it does not have any boundary. You don't know that with whom you are doing the transaction. Maybe you're doing the transaction with your neighbor in India, or maybe you're doing the transaction with someone who's sitting in US or in some other country, but you don't know where the person is sitting. Okay, so there is this kind of crypto trading is global in nature. So there are some more cryptocurrencies other than Bitcoin. So we have Ethereum, we have Ripple, we have Litecoin, we have Tether, we have Bitcoin Cash, that is BCH, we have Libra, we have Binance Coin, we have Matic, which is a Polygon coin, we have some of the Solana coin. So these are all cryptocurrencies apart from the Bitcoin. Now more and more blockchains are coming up and they are creating their own cryptocurrencies. All right, so now let us now understand about some of the use cases, some of the probable use cases of the blockchain. So there is a great disruption by the blockchain nowadays. So as we discussed from the beginning, the blockchain space will have the digital currency in the form of token. It will have a mechanism for record keeping. That is, for example, like IPFS, which is a distributed kind of database, and the securities are in terms of the hashing that is being implemented between the blocks. And so these all are the applications. Like we can implement the blockchain platform. We can have we can deploy the digital rights over the blockchain. For example, we are having the Aadhaar. Aadhaar is one of the largest system in the world. So that this identity, Aadhaar identity, can be hosted onto the blockchain, and we can have the digital rights over with the help of blockchain. So as a citizen, we have either two things with us, that is our duties and rights, kartabya or adhikar. So these duties and rights are basically very important for every citizen, and we can implement these rights and duties over a blockchain. We can also create a blockchain for the wages. That is how we can distribute the salaries, how we can like for example, Manrega is a scheme in India for providing the employment for the unemployed people in India. So how we can distribute the money or wages amongst all the people who are doing the work inside that government employment scheme, Manrega. So that is also a use case which can be implemented over the blockchain. We can also implement the share trading over the blockchain, the equity trading over the blockchain. Okay, so how the shares will be listed, how the shares will be transferred. So all these things can be hosted on a blockchain. Also, we can create the private marketplaces like NFTs, which are like NFTs. That is some non-fungible tokens. Non-fungible tokens. So there are two types of tokens inside the blockchain: fungible tokens and non-fungible tokens. So non-fungible tokens are those which are basically cannot be exchanged by anything. Okay, fungible tokens can be exchanged with anything else. So non-fungible tokens are there, and they are the copyright of a person. So we can create a private marketplace over the blockchain that will host some of the non-fungible type of products. For example, some specific exclusive art, or some kind of old collection of coins, or maybe something which is unique in the world. So that can be available only on that private marketplace, so that we can host on the blockchain. And we can create the platform for the debt system over the blockchain also. Yes, Crowdfunding is one of the very famous and popular use case for raising the money for different causes. For example, if we are running an NGO and we want to raise funds for that NGO, and if we are having these schemes, our plans, and if we can convince the people around the world, okay, please, we are doing this cause. For example, we are providing the education for the children of the unprivileged people, and then we can convince the people around the world who are having money, they can contribute the money, they can raise the money, they can contribute money for that cause. So that can be done with the help of blockchain. That can be one of the very famous use case that is nowadays is under development. Derivatives like the byproducts, or maybe any byproduct of any business, that can also be implemented or deployed over the blockchain. Intellectual properties, like whatever we are developing, like for example, we are having some of the patents, some of the technology, some of the products, some of the model, or anything that we can create, we can put onto the blockchain. Yeah, so yes, voting is one of the things that, like, we can, like, there is a voting system in our democracy. So the complete democracy can be like having a voting system with the help of blockchain. Some small countries like Botswana, and some very small countries in which the population is very less, they have already started this blockchain kind of a system in which every person is voting with the help of this decentralized application online. So transfer of the ownership, land records, the healthcare records, the microfinance, like for example financial inclusion, that is one of the important use case that we can have. E-commerce applications, global payments, remittances of money. So that all are, like, you can see these all are probable use cases, and these probable use cases are not limited. We can have some other use cases also, right? So that was the discussion about the probable use cases. Now I'm going to demonstrate that how we can build our first decentralized application. What are the typical steps that are needed to build a blockchain application? So first of all, we have to define to whom we are building that application. That is, we have to define the beneficiary, and then we have to build a prototype. So how the prototype is there, and how, like, defining the beneficiary of your dApp, whether we have to use a permission blockchain or a public blockchain, and how we can build the prototype. So whether we have to create a mobile application or a web application, or both. So that we have to decide in the second step, and then we will have to develop a front end, and then this front end will be developed with the help of some of the web development tools, like for example React, Express.js, Node.js, MongoDB, and some mobile app will be developed with the help of Swift for iOS, and Java, Kotlin for Android, and React Native for both platforms. So the front end will be developed with the help of web development tools, and then we have to build the backbone. So the backbone will be developed with the help of blockchain-based smart contracts that will be written in either Solidity for the public blockchains, and in Golang or Rust for the private blockchain. And then we will have to find some of the tools that we have to use as a framework for the deployment of the blockchain. For example, some of the online tools, like for example Remix, IDE, or maybe the Hardhat or Truffle or Ganache. So these are the tools which we need as a framework to deploy our decentralized app. And then finally we have to test our app, and then we have to launch and deploy that app over a platform. So these 7 steps are typical steps to build our first blockchain application. So these are some suitable tools for our decentralized application dApp. that, for example, we will use for front-end development the React, because React will be used both for web application as well as for the mobile application. And also there is like for the testing of the smart contracts, we'll use JavaScript, Python, Go, Rust, C++. These are used for backend coding, for the business logic development, and these will be used to write the smart contracts. And then Node.js, Solidity, as I said, these are again the smart contract development languages along with the Python, Go, Rust, C++. And then Truffle is a framework that will be used to developing the smart contracts with Solidity and then testing the blockchain code. So Truffle is basically a framework that will provide you everything like IDE, your connectivity with the databases like IPFS and some old MongoDB kind of databases. And then we have some of the wallets, for example, MetaMask. So I hope many of you has already heard about these wallets, that is MetaMask, Ethereum wallets, Exodus wallet. So MetaMask is an Ethereum wallet that provides the chain connectivity inside a browser, and whatever transaction is done, it is done with the help of these MetaMask wallets. Ganache is used. Ganache is a tool which is used for a local blockchain in seconds with the funded accounts. So we are already having some of the accounts that are in place, and then we can locally deploy a blockchain on our particular machine with the help of Ganache. And this is a very easy option to set up full testing environment or we can have a test bed development inside our lab only. So we can have lab, and then we can test the blockchain applications over Ganache. Yes, Web3.js, and this is very important library. So like we are writing the smart contracts, and those smart contracts has to be connected with the distributed database. So how the connection will be established? So Web3 is basically Web3.js is one of the technology that is used to connect your smart contracts with the front end and also with the databases. Okay, so and then we have Express.js and Remix. So all these are the suitable tools for our decentralized application that we use for the purpose of the development of the centralized application. All right, so we have covered something which is in detail of the blockchain. Now let us took a present perspective on the blockchain. So the research on blockchain is gradually shifting away from cryptocurrencies towards the decentralized ledger technology enterprise applications. So as you know that cryptocurrency was started in 2009 in the form of a Bitcoin by the proposal given by Nakamoto. So that Nakamoto has given the idea of cryptocurrency. So since 2009 till 2015-16, people were only knowing that, okay, cryptocurrency is a blockchain. But now the momentum is shifting beyond cryptocurrencies. The hell lot of applications are there for the blockchain. So the current perspective on the blockchain is now not focusing on cryptocurrencies. It is focusing on all the business use cases which we just discussed. Okay, so the present focus is on like how we can provide the traceability, or how we can provide the provenance. That is how we can prove that, okay, whatever I have committed, I have done it. So that provenance is done with the help of blockchain. So the present focus is to provide the traceability, trackability. And like for example, I took the example of dairy. So Nestle's milk supply chain blockchain prototype to trace the milk source. So how you trust that the milk is fresh. So basically, maybe the milk was produced maybe 15 days back, then it is preserved in some warehouse, and then those preservatives will be like, so there is a need of tracing or tracking all the actions and decisions that are done with the help of the company. Okay, so the trust is only when you are like taking that from a particular trusted source. So the present perspective is beyond cryptocurrency. It is now not more focusing on cryptocurrencies. So we can say now the cryptocurrency focus of blockchain is almost becoming past. Okay, and now we are moving towards the development of the different decentralized applications for the other use cases. So yes, so blockchain technology is the future now. So we are like, as you see here, like by 2025, blockchain would add a business value that will grow to over $176 billion. So this would increase further by $3.1 trillion by 2030. So you can see here that how the blockchain is jumping, how the blockchain business will be growing over the years. So this is a forecast which is given by different reports from the gardeners and from the trusted surveyors. So by 2030, it could be used as foundational technology for more than 30% of the global customer base. So you can see that as a business person, as a technologist, as a educationist, so how we have to get ourselves ready for the future, because now blockchain technology is disrupting everywhere. Now it is going to enter in almost every kind of a business. So yes, we saw some of the very bright side of the blockchain, but yes, there are challenges. There are things which we have to take care of. Like, for example, blockchain requires, very, very high computing resources. It requires very, very high bandwidths on the network. So computing resources, communication power. So these are basically decides the performance of the blockchain. So scalability and performance is one of the challenge, because still we are not having that kind of infrastructure for the public use case where we are going to implement. Maybe, but in the down the line 2-3 years, or maybe in the present scenario also, it is not yet affordable. Maybe it will become more affordable down the line 2-3 years. So it is a challenge. Scalability is definitely a challenge. How you will extend your business if you are implementing on blockchain. Then security, like as I said, security is there in the blockchain, but the records are secure once they are stored into the blocks and they are committed over the blockchain, because they are secured through the hashing. But at the time of transaction, because the records are available on every peer, and when the transaction is providing to the peers for the validation purpose, so at that time they are not cryptographically secure. So we have to still work on that part, that at that point of moment we have to secure the transaction when the transaction is basically going from one peer to the other peer for the validation purpose. Yes, interoperability is one of the challenge. That means if we we want to have the interoperability between Ethereum and Hyperledger. So if two blockchains has to be connected, so that now the idea is that to create the chain of blockchains. How we can create the chain of blockchains? So that is interoperability. So interoperability is one of the challenge. Then we have data localization, that how the data will be protected, because it is available over the nodes of every node, every peer. So data localization is one of the issues, that how we can provide the data even it is not duplicated over the nodes. So these are the challenges which are there to implement the blockchain. So let me conclude my session. So basically, blockchain is an emerging technology which can drive the business logic in future. So it works as a trust exchange of the digital world. So a blockchain consists of a process of recording transactions executed by peers through a common consensus algorithm in an immutable peer-to-peer distributed ledger using smart contracts and other technologies. So it uses the distributed ledger technologies, which consists a data model, a language of transactions in the form of like Solidity or Golang or Rust or maybe some Python or C++, and a consensus algorithm. So blockchain is either permissioned or non-permissioned platforms. So as a conclusion, we can say that basically blockchain is definitely entering into the business domain. Now many of the business houses has already migrated their business onto the blockchain, or the government agencies are thinking in terms of the blockchain's deployment. But still, as an educationist, as a researcher, as a business person, how we have to adapt ourselves in the changing scenario, so that we have to think about it. So that's all from my side. I am done. If there are any questions,